78 are there. First I will take the attendance, then we will go for the lesson.
Good morning, sir.
Yeah, okay. Yes, now we will go for the screen sharing. Yes. Screen is visible?
Yes, sir.
Okay.
Yes, sir.
Okay. So yesterday we discussed about the Compton effect. So again, once again, we will discuss briefly about the Compton effect. Okay. So for explaining the Compton effect here, instead of classical mechanics, we are considering quantum mechanics. Quantum mechanics, according to quantum approach, so that wave have dual nature. That means light have radiation have dual nature. That is the wave nature as well as particle nature. Okay, so by using particle nature, we are explaining here Compton effect. Okay, so that means for that here light is considered as a photon. Light is considered as a photon. That photon is collision between the photon and electron. Okay, due to the collision between the photon and electron, so here Compton effect will occur. So first of all, we have to know what is the definition of Compton effect. Okay, what is the definition of Compton effect means? When a beam of light, so here not only single light, when a beam of light is instantaneous substance, any substance here, that if you will take metallic substance, okay, anything. So when a beam of light is instantaneous substance, so what happened means here there are two types of radiation will be emitted out. Two types of radiation will be emitted out. So one radiation is without any change of the energy or wavelength. Okay, and another one is, so there is a change of wavelength. There is a change of wavelength. That means energy is decreases. Energy is decreases. Here, this is applicable for high energy. That means lower wavelength radiation. High frequency radiation or lower wavelength radiation of light beam is instantaneous substance. Some part of light beam is coming without scattering. Some part of light will be scattered. Some part of the light will be scattered. Okay, so that scattered light have compared to the instant light, scattered light have less frequency, less frequency or high wavelength. Okay, so that is the Compton statement. That is the Compton effect. Okay, now coming to the, so already we discussed how it will be happen. See here. Yeah, so when light is instant on that, so what happened, some part of light is scattered. Okay, here only and we are discussing about the scattered wavelength. Okay, some part is doesn't have any collisions, so that will come out. Okay, some part of light have collision with the electron, collision with the electron. Okay, that only scattered, that light only scattered. Okay, so those wavelength only changes, that light wavelength will only changes. Okay, that change in wavelength is, so lambda dash, original wavelength is lambda, so that change in wavelength equal to Compton shift, that is the del lambda Compton shift. That Compton shift value equal to h by m naught c into 1 minus cos theta. Okay, yeah, so here according to the quantum theory, when photon of energy h nu strikes with the substance of, some of the energy of the photon is transferred to the electron, okay, therefore the energy of the photon reduced and wavelength increases. What is the reason for wavelength increasing of the scattered light means, so here some energy is losses, that photon losses the some energy, that lost energy supplies to the electron, that lost energy supplies to the electron. Okay, so that's why what happened means electron will be recoil from the substance. Okay, here we have to consider some assumptions. What is those assumption means? So the here collision occur between the photon and electron. Okay, so that means that collision is relativistic and elastic. Relativistic and elastic collision. Okay, and the law of conservation of energy and momentum hold good. Okay, these are the assumptions we are taking here. Okay, now here, so we have to consider what is the important factor means. So before collision, what is the energy and what is the momentum? First we have to know. Then only so we can calculate the total calculation. So for that, so first of all here some photon energy h nu is instanting. So that means that photon energy is h nu. That momentum. So momentum p is equal to h nu by c. Already we discussed how we will get at the momentum means. So according to Newton's law, E equal to mc square. Okay, conservation of energy, E is equal to mc square. So that means from that we can write mc is equal to E by c. What is the E here? Energy. Energy equal to h nu. That means so mc means so that is the momentum P equal to h nu by c. So this is the photon momentum. Photon momentum. Now coming to the electron. So electron means here initially electron is at rest. Initially electron is at rest. That means here velocity v is equal to 0. V equal to 0 means momentum also 0. Momentum also 0. So this energy E equal to m naught into c square. E equal to m naught into c square. M naught is the mass of the electron at rest. Mass of the electron at rest. Okay, that means E is equal to m naught c square. So uh, that is the energy of the electron. What is the momentum of the electron? This electron here. So momentum of the initial electron is 0 because electron are does not moving. That means before collision. So before collision, we have to calculate what is the energy, what is the momentum of the photon as well as electron. Okay, so that is the before collision. Now after collision. After collision, so that electron is recoiling with an angle theta. So photon is scattering at an angle phi. At an angle phi. Okay, so now so what is the energy of the photon means h nu dash. H nu dash. Okay, that is the energy of the photon. So nu dash is the change in frequency. So before frequency is nu. So after scattering frequency is nu dash. Okay, so that means here nu dash equal to, we can take c by lambda also. That means hc by lambda also energy. Hc by lambda also energy here. Okay, now similarly photon momentum. After collision, what is the photon momentum means? So p dash. P dash is equal to h nu dash by c. H nu dash by c. Now coming to the electron. After collision, so electron. Okay, after collision, electron moving with certain velocity. So that's why that velocity is v. Okay, and momentum equal p is equal to m into v. And energy is equal to m. What is that here? We are taking energy of the electron is m naught, but electron is moving with a particular velocity. So that means that velocity is approximately equal to the light velocity. That's why here what happen if any particle is moving with light velocity means that mass also changes. That relativistic mass, we will consider that mass is relativistic mass. So that's why here for electron mass equal to m. So okay, m is equal to, already we discussed yesterday, m equal to m naught into, sorry, m naught by under root of 1 minus v square by c square. Okay, so now here mass of the electron, when electron is moving, so that mass is equal to m. Energy is equal to m into c square. M into c square. This is the energy of the electron. Okay, here for calculating the Compton effect, Compton shift, so only we have only 4 steps. What is that means? So first step is conservation of energy. Conservation of energy. So before collision, what is the total energy? So that equal to after collision, what is the total energy? So that is the we have to take. So before collision, what is the total energy here? H nu plus m naught into c square. So after collision, what is the energy? H nu dash plus mc square. Okay, so now so energy is conserved. Energy is conserved. Okay, so that is the energy is conserved means, so we have to take, so both are equal. Before collision energy equal to after collision energy. So from this we are getting one equation. We are getting one equation. That let us take, that is equation number 1. Okay, and both sides squaring it. both sides squaring it. So if you squaring it, so you will get equation 2. Equation 2. So that is in part of energy. That is in case of energy. That is the first step what we have to do. So next step is so momentum. Momentum also conserved. So before collision, what is the momentum? So that is equal to the after collision, what is the momentum? Okay. So here momentum we can divide it into two parts. Okay. So that means here, so actually what is that photon direction is like horizontal direction. Photon direction is like horizontal direction. After collision, so this electron is moving like this direction. That means it's making an angle theta with the original direction. Okay. So and photon also and making an angle phi with original direction. So that's why. So this momentum is we can divide it into two parts. Momentum is divided into two parts. So that means it's have, suppose electron is moving like this direction, means it's moving in both directions. One is the horizontal direction as well as vertical direction. That means its displacement will be like horizontally as well as vertically. That's why this momentum is divided into two parts. So one is the what is that horizontal direction, another one is the vertical direction. Horizontal direction, so we are taking here mv cos theta. Momentum equal to mv cos theta, otherwise p cos theta. So here in vertical direction, so what is the momentum? P sin theta. P sin theta. Similarly, in case of photon also, in vertical direction, so what is the momentum? So vertical direction p sin theta, horizontal direction p cos theta. P cos theta. Okay. So now we are applying here. Okay. So first of all, we are taking in the direction of incident photon. In the direction of incident photon, what is the conservation of energy? So that means before collision. Before collision, so electron is at rest. That means there is no momentum. That's why we are taking 0. So what is the photon momentum? Means h nu by c. So that means before collision, so momentum equal to h nu by c plus 0. So after collision, we are taking only horizontal direction here. Horizontal direction. That's why. So what is the momentum? H nu by c. This is the momentum of the photon into cos phi. Cos phi. Why we are taking means here. So that is moving in horizontal direction. And and another one is the mv cos theta. So this is the electron momentum along the horizontal direction. Okay. So this is okay. If you simplify this equation, so mv cos theta is equal to, so bring this equation that side. Okay. So h nu minus h nu by c cos phi. If you divide with the c both sides means, so multiply with c both sides means it will be changed like this. Okay. So this is the equation number 3. This is the equation number 3. Okay. Now along the vertical direction, vertical direction, if you observe here, so that means in this case there is no vertical motion. There is no vertical motion of the photon. So that's why in the vertical direction there is no momentum. As well as similarly, electron also at rest. So that's why in vertical direction there is no momentum for electron. So that's why in vertical direction there is no momentum before collision. Before collision. Now after collision. Okay, after collision, so here uh, photon is moving like this. Okay, so after collision its direction is like this direction, vertical direction means like this direction. Electron direction is so upward direction. So both are in what happened, opposite signs. Both moments are having opposite signs. So that's why we are taking here so minus sign. Okay. So that's why resultant momentum in resultant momentum after collision is equal to h nu by c, h nu dash by c into sin phi minus mv sin phi. Okay. So now here, so bring so this is this side, and c is here. So that's why multiply with the c both sides. So here c will be cancelled. Now resultant equation equal mvc sin theta is equal to h nu dash sin phi. Let us take this is equation 4. Equation 4. Yeah, if you solve these two equations, so that means how to solve means squaring the equation 3 and 4, and we can add it. Okay. So now if you add it means we can get, so squaring means mvc cos theta whole square, here mvc sin theta whole square. Okay. So that means here mvc is common, so let us take mvc whole square is common. So what is the remaining means cos square theta plus sin square theta. So that means cos square theta plus sin square theta equal 1. Okay, that's why remaining term equal m square v square c square equal to. So if you add both side and if you square it both side and you can add these two terms means you can get this value. Okay, if you simplify it, so we will get the equation 5. If you simplify it, we will get the equation 5. Okay, so this is the step 2. So first step is conservation of energy. Second step is conservation of momentum. So from the conservation of energy, we are calculating the one final equation. So from conservation of energy, we are calculating the one final equation. So by using these two equations, so this is the equation 2. So and this is the equation 5. Okay, so by using these two equations, we can solve this equation. We can solve this equation. So we are subtracting both equation 2 and 5. We'll get another equation. Okay, so in that, here instead of m naught, here instead of there is the m naught term is there. Okay, so that m naught we are converting into m. Okay, already we know that according to the Einstein relativistic theory, if particle is moving with a light velocity, approximately light velocity. Okay, so that means what happened, that mass will be changes. That change in mass m equal to so m naught by under root of 1 minus v square by c square. 1 minus v square by c square. Okay, now if you simplify it, you can get m square c square minus m square v square equal to m naught square c square. Here instead of m naught square c square, so yeah, m naught square, yeah, c power 4 is there. So that's why we are multiplying with the c square both side. Okay, so if you multiply means it will become m square c power 4, m square v square c square equal to m naught square c power 4. So let us take this is equation 7. So this value m naught square c power 4 you can substitute in the equation 6. So if you substitute means so this value and this value will become same. So that's why these two are subtract with each other. So that's why what happened, so it will become 0. LHS side it will become 0. So RHS side, so there is a two terms will be there. If you simplify these two terms, so what you will get, so you will get the relation in terms of frequency. Okay, if you simplify this, this means what we will get, so 1 by nu dash minus 1 by nu is equal to h by m naught c square into 1 minus cos theta. So here what we are doing means instead of nu dash, that means there is a relation between frequency and wavelength. So what is that relation means, nu is equal to c by lambda. Okay, so now instead of nu we are substituting here c by lambda. So if we substitute like that means, so what we will get, so there is a lambda shift, lambda dash minus lambda equal to so h by m naught c into 1 minus cos phi. This is the lambda shift here. That shift we will call it as Compton shift. Okay, so here, so this is the Compton shift here. Suppose here phi. So what is the phi means, so angle of the scattering. So photon is scattered with some angle, so that is the phi is here, angle of the scattering of the photon. Okay, if phi is, so here if you substitute, there are the three cases will be there. So those cases will be depends on the here angle phi. Suppose if phi is equal to 0, phi equal to 0 means cos phi value 1. If you substitute phi is equal to 0, so phi equal to 0 means there is no scattering. Okay, so phi equal to 0 means there is no scattering. So if you substitute phi equal to 0, cos 0 equal to 1. So that means cos 0 equal to 1 means 1 minus 1, 0. So that means there is no lambda shift. There is no Compton shift. If that means if photon is doesn't have any scattering, so that means so there is no lambda shift, there is no Compton shift. That means so in statement we are considering there are after that means after scattering, that when a light beam is instant on a substance, what happened, some what is that, some photons are come out without any change of the shift, without any change of the energy. Some photon have increases their energy, some photons have decreases their energy. So which type of photons means, so if phi equals 0, so the photons are coming directly Directly means, so there is no collision occur, so for that photon. So that's why there is no scattering for that photon. Okay, so that means if phi equals 0 means there is no Compton shift. There is no Compton shift. Okay, now second case, if phi equal 90, if phi equal to 90, so cos 90, so cos 90 value is 0. Cos 90 value is 0. So that means here shift is equal to h by m naught into c. H by m naught into c. Okay. Suppose if you will take third case, so phi is equal to 180. So cos 180 value minus 1. Cos 180 value is equal to minus 1. So minus 1, so it will become plus 1. That means here Compton shift 2 lambda is equal to 2h by m naught into c. 2h by m naught into c. Okay, shift will be high at, so phi is equal to 180. Phi is equal to 180. Okay, so phi equal to 180 means how it will be behave like this. See here. Suppose this is the phi we are taking. So that means here phi equal 0 means, so light will come directly like this. So photon will come directly like this. If phi is equal to 90, so photon will come like that. Okay, if phi equal to 180, so 180 means photon will be get back. Photon will be get back. Okay, so this is the Compton shift. This is the Compton shift here. So there are three cases will be there. So one is the case 1 equal cos phi equal the phi equals 0. Phi equals 0 means there is no Compton shift. So phi is equal to 90 means that Compton shift equal to h by m naught into c. So if phi is equal to 180 means, so that shift equal to 2h by m naught into c. So that means at that case, third case, what happened? So that total photon will be reflect back. Okay, now so from this we have some conclusion. So the wavelength of scattered photon lambda is greater than the wavelength of the incident photon. Okay, so wavelength is, that means energy is less means wavelength is greater. Okay, so del lambda is independent of the incident wavelength. So here it does not depends on the whatever the incident wavelength, because it only depends on the, here h is constant, h is the Planck's constant, m naught is the, so mass of the electron, c is the light velocity. This also total constant. That's why it only depends on the scattering angle. Compton shift is only depends on the scattering angle. Okay, so del lambda is independent of the incident wavelength. Okay, now del lambda have the same value for all substances containing free electrons. Okay, so that means it does not depends on the substance also. It does not depends on the substance also. Okay, so and del lambda is only depend on the scattering angle. Del lambda is only depend on the scattering angle. Okay, now direction of the electron. So now we are discussing about the only about the, so scattering photon. Okay, so now we are discussing about the, so what is the direction of recoil photon. Okay, so we get the equation 3 and equation 4 here. Okay, this is the equation 3 and this is equation 4. Okay, so both divided, that means equation 4 by equation 3. So do the equation 4 by equation 3. That means here MVC is common for both. That's why it will become sin theta by cos theta. Sin theta by cos theta. Okay, sin theta by cos theta is equal to tan theta. So tan theta is equal to h nu dash sin phi by h nu minus h nu dash cos phi. Okay, so if you simplify it, we can get, so this is the tan theta is equal to, so lambda sin phi minus lambda dash minus lambda cos phi. Okay, so this is the direction of recoil electron. Here theta is the angle between the incident direction of the photon and angle the recoil electron. Okay, so here, so tan theta, this gives the direction of the recoil electron. Okay, so now what is the energy of the recoil electron? Energy of the, so recoil, that means kinetic energy of the recoil electron. That means so it will be emitted from the substance. It will move with a particular velocity. If it will moving with a particular velocity means it have some kinetic energy. So what is the kinetic energy? We have to calculate. So that kinetic energy is equal to, so that means here photon will losing some energy, na? So that initially it's have some energy h nu. So after collision, what happened? That photon have h nu dash energy. So that means photon lost some energy. That what is the loss of energy means h nu minus h nu dash. H nu minus h nu dash. Okay, so now, so if you solve it, hc by, that means here nu is equal to c by lambda. Okay, if you substitute it, hc by lambda minus hc by lambda dash. If you take the common hc, 1 by lambda minus 1 by lambda dash. Okay, if you simplify it, you can get E is equal to hc by lambda dash, sorry, lambda dash minus lambda here, lambda dash minus lambda by lambda dash. Okay, so this is the, what is that, energy loss of the photon. That energy loss is supplies to the electron. That energy loss of the photon is supplies to the electron, and it will be converted into kinetic energy of the electron. What is the kinetic energy of the electron means? So what are the energy loss of the photon? That is the kinetic energy of the electron. So kinetic energy of the electron equal to hc by lambda dash minus lambda by lambda dash. So this is the, so kinetic energy of the recoil electron. Okay, so this is about the Compton effect. This is about the Compton effect. So anyone have any doubt on this, students? Any doubt on this Compton effect? Okay, so I think everyone understood this. Okay, this is very important one. Okay, so I explained 2 times. Okay, so just simply, so before scattering, what is the, before scattering, what is the momentum, what is the energy, we have to find out. So after scattering, what is the momentum, what is the energy, we have to find out. And after that, so what is the so we have to apply the conservation of energy. So we will get conservation of energy, nothing but before scattering what is the total energy, after scattering what is the total energy. So that is the, so conservation of energy. Next, conservation of momentum. From the conservation of energy we will get one equation. From the conservation of momentum we will get another equation. So if you solve these 2 equations, means we will get the, so Compton shift, we'll get the Compton shift. So that is the, so very easy one. Okay, yeah, now coming to the, now we will go to the next one. What is that means? De Broglie wavelength, de Broglie hypothesis. Okay, so de Broglie, before going to the de Broglie hypothesis, just we are discussing about the, so what is the wave, what is the particle, what is the wave, what is the particle. Already we have some idea about what is the wave, what is the particle. Okay, so if you what is the wave means? Here wave is nothing but spreading of disturbance over a large region. That means here wave is nothing but spreading of disturbance over a large region. Okay, so if wave is traveling, means it will be spread, so throughout the area, throughout the area, and disturbance to surroundings, Okay, now specification of the wave. So it should have wavelength. Wave is nothing but, if wave will be there, means you should have wavelength, and you should have phase. Phase means in which direction it's traveling. Phase is nothing but in which direction it's traveling. It should have some phase, and it should have amplitude and intensity. Amplitude is nothing but wave, it's travel like a, you know that sine wave, so it's go up and down, Okay, so up and down means it's so in positive direction it's have what is the some maximum point. In negative direction there is a maximum point. That maximum point we will call it as amplitude. Okay, you should have some amplitude, and it should have some intensity means, so number of waves traveling through a unit area. Okay, so that is the intensity. So these are the specification of the wave. So this is about the wave here. And evidence. So that means here we are discussing about the, so light is traveling like a waveform means what is the evidence. That means here so there is some experimental results like that. That is the interference. Okay, so interference, by using interference phenomena, we can set that, so light have wave nature. Similarly, diffraction phenomena, we can set that, so light have wave nature. Okay, so polarization, X-rays, gamma rays, UV rays, etc. show the radiation. So these all have, so based on these all, so we can conclude that, so light have, other radiation have wave nature. Okay, this is about the, so wave. Okay, now coming to the particle. So understood wave, what is the wave?
Yes,
Yes.
sir.
Yeah. So that means if wave nature, it should have wave nature means it satisfy the, that means it interference should be occur, diffraction occur, polarization occur. Okay. So then only, so we can conclude that, so that that light or that radiation have wave nature. Okay. Now coming to the particle nature. Okay. So particle is nothing but matter. Particle is nothing but matter, a substance which occupy some space, some volume, and it has some weight is called.
Some foreign so he gets to live a happy life after he turned all my hybrids against me, after he tried to kill me, after he made it his life's mission to find a cure.
Yeah, due to some network problem here it was disconnected. So due to some network problem here it was disconnected. Okay, we'll start again. Yes, screen is visible.
Yes, sir.
Students audible. Yeah, screen is visible.
Yes, sir.
Okay.
Yes, sir.
Yeah. So we are discussing about the, so what is the particle here? So particle is nothing but matter. Okay, a substance which occupies some space, some volume, and it has some weight is called as matter. Okay, that means what is the specification of particle? What is the specification of particle means? That particle should have mass and it should have velocity and momentum and energy. So these are the specification of the particle. Okay, so how we will set that is the particle means? So that means here in case of light it should have it should satisfy the photoelectric effect, the photoelectric effect, and you should explain the Compton effect. Okay. Newton, according to Newton corpuscular theory, okay, he suggested that so what is the particle nature of the wave, what is the particle nature of the radiation? What is the particle nature of the radiation? He explained on that. He explained on that. This is about the particle nature. Okay, so according to the, so this is about the light we are discussing up to now. So now coming to the, so de Broglie wave hypothesis. De Broglie hypothesis means in this hypothesis what he said is in this hypothesis means according to de Broglie, so that matter is nothing but that particles. Okay, particles also have wave nature as well as particle nature. So that means matter also have dual nature. Matter also have dual nature. So that is nothing but it should have wave nature as well as particle nature. Particle nature. So that is according to de Broglie hypothesis. De Broglie hypothesis. So wave particle dualism of the light as well as material particles. Material particles. Material. So according to already previously we discussed that according to quantum mechanics, so light should have dual nature. So that is it's have a wave nature as well as particle nature. Similarly, so matter also have so wave nature as well as particle nature. Particle nature. Okay. So light wave can act as a wave sometimes as well as sometimes it act as a particle. Okay, so then particles such as electrons should also act as a wave sometimes as well as so particle sometimes. This is known as the de Broglie hypothesis. What is the de Broglie hypothesis means? So wave that means radiation also have that, otherwise lights have dual nature. Sometimes it act as a particle nature, sometimes it act as a wave nature. Similarly, so matter also have sometimes it act as a wave nature as well as some particle nature. So this is the de Broglie hypothesis. De Broglie hypothesis. Okay, according to de Broglie hypothesis, any moving microscopic particle is associated with a wave. Okay, that means if any particle is moving, particle means like electrons, protons, like that. Okay, if particles are moving means, so those particles here especially mentioned microscopic particle. So microscopic particle. So macroscopic means so like balls, buses, whatever. So visible with our naked eye. Those are the macroscopic particles. So those particles doesn't have wave nature. But here, while microscopic particle is moving with a some velocity, that those should have associated with a wave. Those should have associated with a wave. The wave associated with the particle is known as de Broglie wave or matter wave. Okay, the wave associated with the particle is known as de Broglie wave or matter wave. Okay, so the wavelength of the matter wave associated with the particle moving with velocity v is inversely proportional to the magnitude of the momentum of the particle. Okay, so that means here wavelength of the particle. So if particle is moving with some velocity means so that should have associated with wave. So that is associated with wave means that should have wavelength. So that wavelength lambda is inversely proportional to the momentum. Inversely proportional to the momentum. Lambda is inversely proportional to some constant by p. Okay, so that means here that constant equal Planck's constant. Therefore, so here de Broglie wavelength lambda is equal to h by mv. Here m is the mass of the electron, v is the velocity of the particle. V is the velocity of the particle. This is about the what is that wavelength of the wavelength of the particle. Wavelength of the particle. If particle is moving with some velocity means that should have wavelength. That wavelength we will call it as de Broglie wavelength. De Broglie wavelength. The de Broglie wavelength lambda equal to h by p. H by p. P is equal to mv here. Okay, so this is about the de Broglie hypothesis. So remaining we will discuss tomorrow. Okay, so now I will take the attendance here. Don't move everyone. Yeah, anyone have any doubts on this? If you have any doubts means you can ask. Any doubts? Okay, so next we will go for the, so tomorrow we will go for the next topic. So you can leave right now.
Thank you, sir.
Yeah.
Thank you. Thank you, sir.
Okay.
Thank you, sir.
Okay.